In this class, we will be studying how to solve Laplace transforms. Laplace transforms, you can find two types of Laplace transforms. One is called lateral and another one is bilateral. Okay, unilateral Laplace transform, it is represented as x of s, which is equal to integral 0 to infinity x of t e raised to minus st dt. That means you are transforming this x of t, which is in time domain, to a signal in frequency domain. So this x of s, it is actually a signal in the frequency domain. You are transforming the time domain to frequency domain. Bilateral, the only difference is instead of integral 0 to infinity, it is from minus infinity to infinity. That means it is two-sided. Laplace transform exists in two sides. Okay. And there is something called ROC, which is the region of convergence. Region of convergence. Or we can say that for a given value of x of t, for a given value of x of t, the Laplace transform may not converge. The Laplace transform may not converge for all values of s. Okay. And if it is converging to a value of s, that area it is known as the region of the convergence. That means you are performing an integration to obtain the Laplace transform, isn't it? So if that integration, if the output of the integration is a finite value, you can say that your Laplace transform is converging. And that area where it converges, it is called the region of the convergence. Okay, now you are going to find the Laplace transform of some commonly used signals. We can start with the impulse signal, which is a basic signal, isn't it? And you all know what is the value of impulse signal. It is 1. X of t is equal to delta t. It is 1 at t is equal to 0. That means it exists only at one point. So you are going to find the Laplace transform of delta t. The basic step in finding this Laplace transform is writing the equation. First we have to write the equation. Here I am going to find the Laplace transform, unilateral Laplace transform only. Okay, it is not bidirectional. Delta t into e raised to minus st dt. Okay, and where does this delta t exist? It exists only at t is equal to 0. So what will be the integral value? You don't have to integrate. You don't have to run summation because there is only one value, isn't it? So this is e raised to minus stx. T is equal to 0, which is equal to, substitute for t equal to 0, this is e raised to 0, which is equal to 1. So delta t, its Laplace transform is 1 for all values of s. Whatever be the value of s, the Laplace transform will be equal to 1. That means here it converges. The integral converges for all values of s. So what will be the ROC? The ROC will be the entire s plane. And how do we draw ROC is that you will be drawing the real part in the x-axis and you will be drawing the imaginary part in the y-axis. Okay, so we have found the Laplace transform x of t, delta t. Second one is the Laplace transform of the unit step signal called the u of t. So we know u of t, its value is 1 for t greater than 0, isn't it? So when you write the equation to find the Laplace transform of u of t, this is equal to integral 0 to infinity ut e raised to minus st dt. This is equal to, what is the integral of e raised to minus st? It is e raised to minus st divided by minus s. You are integrating with respect to time. So this minus s is a constant. Come down minus s. Apply the limit 0 to infinity. So this is equal to minus s is a constant. You can take it outside. Minus 1 by s into e raised to minus infinity minus e raised to 0. And what is the value of e raised to minus infinity? It is equal to 0. What is the value of e raised to infinity? It is equal to infinity. And what is the value of e raised to 0? It is equal to 1. So this is equal to minus 1 by s into 0 minus 1, which is equal to 1 by s. Isn't it? So how do you find ROC for these all cases? The simple thing is that you have to take the denominator and you have to substitute for the real part of the denominator should be greater than 0. Here it is the real part of s, denominator is s, isn't it? It is greater than 0. That is the ROC. That means x-axis, this is the real part. This is the negative real part, isn't it? So if the real part is greater than 0, this will be the area. This is the imaginary part. So this is the ROC for 1 by s. Okay. Similarly, you can find ROC for every signals by using this equation alone. Let us find the Laplace transform of one signal called e raised to at ut. Okay, this is one signal. You are going to find the Laplace transform. So how do you solve? You write the equation integral 0 to infinity e raised to at ut e raised to minus st dt. Okay, so ut is 1 for 0 to infinity. You can take that value as 1 and substitute in this equation. This is integral 0 to infinity e raised to that is at and e raised to minus st. Take t outside. So this will be equal to a minus s. Okay, I am writing like this to show you something. Okay, e raised to t into a minus s dt. So when you integrate, you will get something like e raised to a minus s divided by a minus s from 0 to infinity. There is a t also. Now you have to substitute for this t, isn't it? So this is e raised to infinity minus e raised to 0 divided by a by s. Now the problem comes because your integral value does not converge here. What happens is there is an e raised to infinity which will come to infinity. So you should not do like this. What you have to do is you have to make the equation a small transform such that at the end when you integrate you will get this value as e raised to minus infinity. So what you can do here is you can write, so you cannot do like this. Okay, so instead what you do is you write integral 0 to infinity e raised to, instead of taking this positive t you can take it as minus t. Okay, when you take it as minus t, you have to write minus a plus s, because you have taken negative outside. This negative you have taken outside, so this will become minus t. This is also minus a and this is plus a. Now it will easily become negative infinity, isn't it? So this is e raised to minus t into s minus a divided by s minus a minus of s minus a from 0 to infinity. So this is e raised to minus infinity minus e raised to 0 divided by negative s minus a, which is equal to 1 divided by s minus a. Now how do you find the ROC? Take the denominator, the real part of the denominator, that is s minus a should be greater than 0, which implies that s is greater than a. Take this a to the right hand side, negative a right hand side. When it reaches there, it will become positive a. So s greater than a means there is some value called a in the real part, and when this s is greater than a, your Laplace will converge. So this is the ROC. Okay. Now you try to find out what is the Laplace transform of sine and cosine functions. Okay, x of t is equal to cos omega t ut. That is a cosine function. Now how can we write this cos omega t? This cos omega t is equal to e raised to j omega t plus e raised to minus j omega t by 2. You simply substitute this equation in the Laplace transform equation. Instead of cos omega t, substitute like e raised to j omega t plus e raised to minus j omega t divided by 2. And solve this equation in the same manner as we have explained earlier. Okay. And you will get the Laplace transform of cos omega t into ut is equal to s divided by s square plus omega square. ROC here will be real part of s greater than 0. And similarly, Laplace transform of sin omega t u of t will be equal to omega divided by s square plus omega square. Okay, because sin omega t you can substitute like e raised to j omega t minus e raised to minus j omega t divided by 2j. Substitute like this and you will solve, you will get the final answer like this. Okay. Now I will tell you how to solve some questions like x of t is equal to e raised to minus t u of t plus e raised to minus 4t u of t. Okay. So here there is two terms x1 of t and x2 of t. So we can write the equation for Laplace transform for these two terms separately, that is integral 0 to infinity e raised to minus t ut into e raised to minus st dt plus integral 0 to infinity e raised to minus 4t into u of t into e raised to minus st dt. Okay, you can write the equation separately like this. Now when it solves, it will become 1 by s plus 1 plus 1 by s plus 4. Okay, solve these two separately, you will get something like 1 divided by s plus 1 plus 1 divided by s plus 4. Now how do you find the ROC? Okay, so take the first equation, the denominator is s plus 1 greater than 0. You will get s greater than minus 1. Solve the second equation, s plus 4 greater than 0. You will get s greater than minus 4. Now take the s plane and you mark minus 1 and minus 4. One says that s is greater than minus 1. So that means it is this area, isn't it? To the right side of minus 1. One says that s is greater than minus 4. So between minus 4 and minus 1 you can say that there are no common portions, because if it is greater than minus 4, it is the region that is shown with this red line. If it is greater than minus 1, it is the area that is shown with that black dotted lines. So if take the intersection of both, when you take the intersection of the both, this portion is missed out, minus 4 to minus 1. So what will be the ROC? Both points intersect only after this minus 1. So this will be the ROC. Now take another equation, x of t is equal to e raised to minus a mod t. So here instead of t it is mod t. So what is the value of mod t? Mod t has two values, minus t and plus t. Minus t for time less than 0 and plus t for time greater than 0. If the time is less than 0, it is minus t. If the time is greater than 0, it is plus t. So when you write the equation, it will be integral 0 to infinity e raised to minus a into positive t into e raised to minus st dt plus integral minus infinity to 0. Okay, both areas you have to mark, minus infinity to 0 e raised to at into e raised to minus st dt, because minus a into minus t, it is plus at. You will get the answer as 2a divided by s square minus a square. Thank you.